So the API or the code to the left of the media service is largely unchanged, mostly unchanged. But the we have the ability to branch out to or cascade now horizontally, which is nice. So a given room has a lot of peers, and we handle the connections from the peers using middlewares for various functions. The same thing actually is true for the media nodes. So a media node in this picture is represents a connection to one of the actual media nodes out there. And that in the same way that the Edumeet client has a connection to its peer object, the Edumeet media node has a connection to its media node counterpart on the server, and talks to that using middleware, which again interfaces with the media service. And yeah, you have closed the loop so that messages can flow back and forth. I will publish this in the Slack channel at some point.
And additionally, we should also say from this picture the repositories.
Yes.
Just to say it again, that media nodes.
Yep. Let me bring it back up, I suppose. So the Edumeet client, I named them after their repository names here. So the Edumeet client is, the repository we know and love, and the Edumeet room server is the new room server and is named the same as this name here. And the Edumeet media node is also named the same. So go look for these repos and you will find them under these names.
And the Edumeet room server actually.
Yeah, so the Edumeet room server.
Two branches?
No, the Edumeet. Well, all of them have two branches. They have main and develop. The Edumeet client has an extra branch called old room server, which is a branch of the client that interfaces the client with the old room server. The main Edumeet repo has a version 4 branch now that is the branch that the new Edumeet client can talk to using its old room server branch. That should be it, I think.
Yeah.
All right. So I don't know if we should go through code in any way. I'm not sure that actually is necessary.
You could just not how it's done, but especially how the files are organized.
Yeah, I can do that. The main entry point in both the room server is on the right here, and the media node is on the left. So both have an entry point called server. The media node has no config. You supply parameters when you start it. So it's very simple to start up. The room server, though, has a bit of config in a config JSON where you, for example, need to supply the array of media nodes that this room server has with their respective host names and ports. On the room server, we have a server manager, which is our general over-encompassing class that sort of handles everything in relation to the server. So whenever a connection comes in from a peer, as in an Edumeet client, we just instance a connection object, and we throw that connection object into the server manager to handle from there. So that's our main entry point and main manager of the entire server. It has a media service, and yes, like we saw, so there is one instance of the media service which gets thrown around everywhere to whoever needs it. We have a the server manager then has a map of all the rooms and all the peers that exist at any point in time on this room server. So whenever a connection comes in, it comes in through this handle connection, which has a reference to the actual connection from the client. And then we instance a room and a peer object, and we put the peer object into the room. So that's how that gets set up. And the function that takes over from there is the so room add peer. So in the room class, we have an add peer, which is the entry point for a peer into the room. So at that point, the room class has taken over the ownership of the peer, and will see the peer through its lifetime. This also then is our main join logic. So here you can either end up in the lobby or you can be allowed to enter. And this has the various functions to actually move them around from the lobby to the join logic and back and forth, and being able to notify peers of various things that happen, and simple management of the peers inside the room. So yeah, that's the main logic there. The peer object is the wrapper around a connection from a peer, or several connections from a peer, and is the representation of a Edumeet client out there somewhere. It's the same roughly as the old room server in what it has. It has an overview of all of the transports, consumers, producers, and so on. And it has the middleware pipeline that we pipe all incoming messages through. So whatever function on the server wants to interact with whatever comes from the client, add a middleware to this pipeline, and it will get it will be in the pipeline to handle that message in any way it wants to. Which means that in the on a notification or request, then you can see we execute the pipeline with this context object, which has a reference to the actual message that came in. It has a reference to this peer instance that this message came in through. It has a blank response so far, and it has a boolean saying if this has been handled by any middleware along the way somewhere. And that is it, really. And you have the functions to send an outbound message or request to this peer from the server. It extends. So the connections extend the base connection class, which is a very basic interface for how a connection should behave and what functions it should provide if you want different types of connections. The middlewares then, if we actually look in the room object again, we see we have various middlewares we instance here, which can be thought of as our functions in a room, what should be available as things to do in the room for a peer. And whenever we where are we? Allow peer. So allow peer, that's you are allowed to enter the room. You are not parked in the lobby. Here you can see we, for example, add the here's the peer object, here's the pipeline, and then we add a middleware to the pipeline. And we add the initial media middleware, and we add the join middleware. So that means that the initial media middleware is added, which gives the peer the ability to get router capabilities. It gives the peer the ability to create WebRTC transports, connect them, and restart ICE. And the join middleware makes it able to do the join command, which will set up various piping and notify other peers that you have entered and so on. And you can see if the peer then actually does the join, we will do room join peer with the peer, which will take us back to room here. And here you can see at that point, we remove the join middleware again. because you're not supposed to be able to join twice in a room, so there's no use in having that anymore. We keep the initial media middleware on because you should still be allowed to create more transports if you want to. And then we move you from the pending peers to the peers in this room so that you are now effectively joined. But before that, we add all the other peer middlewares we have, which are the display name and the raised hand and so on middleware. It's the moderator middleware, general media middleware, as in producing, consuming, and so on. Chat, file, locking, lobby, and breakout. So yeah, various functions are then added to the peer to be able to do in the room. And that is it, really. So the life cycle then is handled by the client, as in the peer, then doing various functions on the room, either producing media or at some point closing down their connection. And at that point, whenever a peer is done, we will remove the peer, which will remove the various middlewares you had on and clean up everything and close down the room if the room is empty. So that's the client side of that. Then you have the media side of it, which is encompassed in the media service. So right now, this media service just loads the media nodes you have in your config. And it, at the moment, has no logic in how it selects a media node other than just round robin add you to the next in the index. So this was just for testing piping. It then asks that certain media node for a router, which is it's not a media soup router, but a shimmed router object that has a socket underneath that talks to the media node. So yeah, the same way the old media service had the get router function, this has the same. And you then, yeah, from that point on, from the room's perspective, everything acts the same. But from the media node and out, we have some new stuff, which is under the media folder here. Here you have the media node itself, which is a, like we saw, fairly similar to the peer object. It can have a connection. It can also not have a connection. So as long as you have no media flowing, we close down the connection. Because there's no, when we have 1,000 media nodes, we don't want to keep 1,000 connections open. So we close them down when we don't need them. We have pending requests, which just is a get router call that hasn't been fulfilled yet. So if while you're waiting for the router in that call, the previous one closes down, and you at that point don't have any other routers in the room, it would have closed down unless we take care of blocking it if there are pending requests happening. This has a map of all the routers that this media node has created. So again, this router is a shimmed object. We will look at it here. Get router done. As you can see, it will create a pending request. It will check if I don't have a connection yet, I will create a connection. And then I will wait for that connection to be ready. That is indicated by the media node replying with a notification, or rather sending a notification, media node ready. When you get that message from the media node is ready to handle this room server request, and this promise will resolve. Then we send request to the media node to create a router and give us back the various things we need to create our local version of that, which is this router object here, and that's the extent of the media node. So there's nothing else. From that point on, you don't interact with the media node more than that. You just use it to get a router, and from that point on, you do everything on the router objects. the same way we do in MediaSoup. You just create a router, and from that point on, you create transports or create whatever on the router object, not on the media node object. So a router has a reference to the connection to the media node, so that if the connection dies, we will kill this router. It has the various things we need for a router. It also has a map of all the WebRTC transports, the pipe transports, producers, and pipe producers on this on this router. Here you can see we have the middleware again. So this router here will add its router middleware to the pipeline, the middleware pipeline of this connection to this media node, which means that at the point of creation, this router will inject itself into the path of the incoming messages from the media node. So from that point on, this router can intercept the messages coming from the media node. And the router, as any MediaSoup router, has a can consume function. It has a create WebRTC transport function. It has a or method rather, and pipe transport, and it also has a pipe to router method. And that is it, really. So yeah, it works the same way the MediaSoup native API works if you use that locally. I have just extended it to now use external media nodes instead. Yeah, so that means that for anything we do on the room server, the logic is the same and the code is the same because the function calls are the same. So there's no difference. So if it worked before, it should work the same now. This pipe to router, which is the same one we have used internally before, that is able to pipe between any arbitrary routers on any arbitrary media node, or between rather. So that means that if you on this particular instance of the router say pipe to a router here, then that is on a different media node, that's perfectly fine. That will just seamlessly work. So you're not restricted to doing this on a local host only. You can pipe between any arbitrary media node and any arbitrary router, and this with the same API that's the local MediaSoup API is.
And that means, and that's really a big step, or the biggest effort here with all this media node stuff.
Indeed.
That the room can scale to the whole infrastructure, not only one server.
Exactly. And yeah, so from this point down, as you will then probably understand, is if we look at create WebRTC transport, for example, that again calls a request that will create a WebRTC transport object that again just wraps the functionality of a WebRTC transport object, but shimmed through a connection. So there's no difference there. So this again is a WebRTC transport object that I created that has a reference to all its consumers, producers, and has various functions you can call that again just send a connection or request to the media node again for that respective function, and that's it. And this has the function again to produce the same way the native media node media service native MediaSoup API has, and so on, all the way down till the producer consumer level. And at that point, we can move over to the media node itself, I think, which has a again server entry point. That was wrong. Give it back. And so yeah, entry point through the server. We have a map of the room server connections, and we have a map of the room server representation on this media node. So a media node can get incoming connections from whatever room servers are out there. So whichever room server wants to can use this media node, and any one of these room server instances represents one room server out there talking to this media node.
And they can do that at the same time in parallel, right?
Yeah. So the media node can be used by anyone. We create a media service. This is really the same media service we had on the room server before. I just moved it over to the media node instead. So all that logic resides here now. And then we listen for incoming connections, and we instance this connection representing the incoming connection from a room server. We put it into this room server construct, and we are off to the races. So the room server, like I said, this one instance represents one room server out there talking to us from the media node's perspective. This has various middlewares, again, same concept as the room server, that we register on the connection from this room server. And that is it. So we just add those. When we are done doing that, you can see we notify the room server that the media node is ready. That was the signal to indicate that the connection was ready on the room server side. If we look at, so there is not a lot of code in the media node, really. That's same code here we had in the room server, essentially. And we just have these 4 middlewares. That's it. So on any middleware, you can see here the room server can do a get router, which we saw in the media node. So here you can see this request on the room server side will enter through this handler on the media node side. And here you see we fetch the room ID from the request, which we sent here in the data from the room server side. So that gives you an idea how this actually works. This just does the same get router that we did on the media service when it was on the room server before. So no change there. We get the router. It may be a new router. It may be a router we already have created at some point before for this room. And we just observe it for close to notify downstream room servers if it's closed. And then we respond with the ID and RTP capabilities here. And you can see those are the ones we receive here as a response to this request on the room server side. So that means we have now successfully sent a request from the room server side that the media node has gotten. It has created an actual media soup router for it, fetched the various ID and RTP capabilities from that object, and sent a response back to the room server. And that's when we pass further into the router object in the room server. So that's an example of that. And of course, you have the close router message you can get from the room server whenever they want to close the router. And this goes the same for any of these you saw. So create pipe transport, create WebRTC transport, and so on. Everything is here. So no big surprises there. And like I said, holds true for pipe producers, consumers, and everything. And that is it. And I guess on that note, we can give a demo of it, I suppose. Let me restart the media nodes just for completeness sake. So do I have a window open? No, I don't. So let's start up the media node here. So we start this on port 3001. This one we start on 3002. And this we start on 3003. And in our room server, in our config, you saw we have 3001, 2, and 3 here. So those are all registered there on the room server. Just for completeness sake, again, let's actually start the room server now, just so you see that it's actually running now. Let me bring up all the nodes again. So 3001 to the left, 3002 in the middle, and 3003 in on the right. And let's then go to, let's hope the demo effect doesn't kill me today. So watch closely on the logs. The room server is all the way in the back, and the leftmost media node now should get it. And it did, as you saw. If we duplicate this, it should now hit the middle one, and it did. So at this point, we are now piping between arbitrary media nodes, not on the same host. And for good measure, let's take a third. And you now saw all the media nodes are engaged in this. So now we have piping between 3 arbitrary media nodes. And just again so now it should loop back and join me through the first media node again. And it did. So that just works. And if I then kill this connection here, which is my one connection to the third media node, you will see that that closed and yeah, works. And closed and works. And closed and works. And if you go back, it should just work. And cleans up that. Yeah, so since it's mimicking the same API that the Media Soup native API has, the code is no different, and it should just work the same.
Just say a word why there are so many media nodes involved in this right now, in this very small room.
Why? What do you mean by that? I started 3, and right now it's just round robin. Drop you into the next media node, next media node, next media node, and loop back to the first one. So any new client will be dropped into the next media node.
Yeah, which is not very meaningful in production.
So that's just for now while we're testing.
To see that it actually works, right?
So here you can see
that every participant should be on the same media node until load or other bandwidth location is not good enough.
Yeah. So here you can see I just take the next one in the array and loop back on to 0 again when we have reached the end. But so it's just an example to show that piping actually works, and we can share screen and it just works. And we can add a different camera, for example. And again, it gets piped to wherever it needs to go and just works.
What happens if you kill a media node while you are in a row?
I haven't actually tested. I don't know. So let's see. So there, I killed it. And that seems to be the node that this client was on, but these 2 clients have a media node up and running still, each. So yeah, there needs to be more logic in handling gracefully these types of things. For now, it only connects and assumes that it works.
And what is the way to check if a node is running fine?
No way to do that at the moment. We would add some sort of application level ping, I think, would be meaningful. And so yeah, so as you can see, the media node connection actually closed here. So the room server cleaned up after itself, but the client never recreated the media it had. So let's see actually what happens if I do this now. No, so it's locked to that media node essentially. So we have to have some graceful handover there. If the media node connection is killed, you will gracefully bring stuff back up on a new media node. But that would be the same for doing it locally as well. So if your worker died or a router was killed, then you would need to bring it up again anyway. So same logic. Yep, that's it, I think. That's the entire walkthrough, I think, unless there are any other questions.
I think there are a lot of questions, but that was very useful. I think I will just restart the recording to be sure that it's actually recorded.
Do it.